Hello, everybody. Welcome to Drunk with Questions. I'm Gooch.
And I'm Raj. Join us as we navigate the complexities of life. Here, alcohol may not be the answer, but it's sure as hell worth a shot.
Hello, everyone. Welcome to Drunk with Questions, the talk show where ordinary people talk about extraordinary topics. I'm Gooch.
And I'm Raj.
Alrighty, kids. Welcome back, season 2. It's exciting. I'm happy to be here. Frankly, we were on the fence on whether or not we would do it, but we decided to do it. Give it a chance, right? Sorry, Raj has his mouth full.
I just got some gum in my mouth. I'm sorry. I apologize. But yeah, we wanted to take a break after season 1 ended and take some time, during the holidays, spend time with the family, and kind of just brainstorm and come back again for season 2 with some more topics and some more ideas that we wanted to discuss. You guys definitely showed us by the number of watches, what kind of topics you guys really resonated with, and we want to kind of focus on that and try to provide you guys with topics while at the same time keeping things diverse, so that way we can actually have conversation about different topics every week. So we wanted to start off today with a space episode. We did a space episode last time, and we wanted to do another episode on it because there's just so much to space and so much that we don't have time to even fully cover in 2 episodes, let alone 5 or 6. There's so much to cover, so we wanted to take some time.
What we wanted to talk about last time, so
yeah, no, it was just arguments and conversations about whether or not Gooch was going to Mars for his snoo. So that was the extent of our conversation.
Well, for season 2, everyone that has listened to this podcast knows that normally I burn Raj as hard and deep as I can.
I love it.
And we were thinking of new things that we could do.
Mm-hmm.
We were like, we could have Raj burn us, or everyone could try to burn Raj, or
why?
I don't know.
What's wrong with, why y'all doing this to me? I don't understand.
It's because you're different, honestly, Raj. No,
yeah, just different from the rest of us, folks.
But instead, we decided that we would spark every episode with a thought experiment, which I think was a better plan. Burning Raj was fun, but I was running out of things after 14
There's
episodes.
only so much you could do.
Yeah, especially if you want to let Raj keep his job. So
yeah. There's only so much he can say without absolutely destroying my life for good. So yes, I appreciate the change over. We're gonna go ahead and try something new. We really like the idea of thought experiments because we want our conversations to be thought invoking. We want you guys to listen to our podcasts and have conversations with your friends and family about similar topics. So I'll have Gooch go ahead and share the topic for episode 1 for the space.
Yeah, space. So mandatory space episode 2. The quantums of physics, or whatever you said earlier.
Madness of madness of space. Yeah, there's a lot of different things we could have done, and we'll set up on a title. Once again, guys, feel free to correct us if we go into anything that's incorrect or we're saying anything. Please reach out and let us know, so that way we can redact it for the next episode. But we wanted to have a fun little episode. It's just going to be me and Gooch starting off, and then Spicy is going to be joining us a little bit later. And we're going to kind of kick it off with the question we have for each other, and then the question we have for you guys. So go ahead, Gooch.
All right. So this thought experiment is called Beer Dan's Ass. So imagine a donkey. He's placed precisely between 2 identical bales of hay. The donkey has no free will and always acts in the most rational manner. However, as both bales are equidistant from the donkey and offer the same nourishment, neither choice is better than the other. So the question is, how can the donkey choose? Does it choose at all, or will it just stand there until it starves? No free will.
The donkey has no free will?
No, so he has to make the choice between the 2. He can't just walk away from them.
And he's equidistance from either of them?
Yep, and they're the exact same.
it'll be random chance. It's a 50-50. There's no, yeah, it's a 50-50. If there's no free will, there's no motivation for the donkey, and there's not going to be any reason. If he's not facing one bale or the other, he's standing directly in the middle. It's going to be 50-50. He'll just turn his head one way, look at it, and then start eating.
It's very that's you assuming an extremely animalistic view of the donkey, which he is, don't get me wrong. But assuming there's no outside stimuli, I think he would be more likely to go towards the bale of hay that he's most likely to turn his head towards first. So,
That's 50-50.
no, that's not 50-50 because if you were the farmer and you knew the donkey and you knew the donkey, I don't know, is left-handed. I'm sure they are. I don't know enough about
No.
equines, but I'm
Yeah.
sure they do have dominant sides. Wouldn't you think that that would make it more likely that it would go?
Yeah, but that's an outside influence we weren't taking into account. This is a completely neutral system where the donkey's in the middle, no favor left or right. He's between two stacks of hay that's exactly the same amount and going to provide the same nourishment. And the only thing that's going to come into play is whether or not the donkey turns left or right. And that is random chance.
So if his dominant side, if that is a thing, isn't a factor, then how can we say that hunger is a factor in that statement then?
Well, he's going to be hungry. Whether or not he's going to be hungry the entire time he's there until he starts eating. But whether or not he turns left or right to satiate that hunger is not based on whether or not you're left dominant. If you're hungry and you have a cheeseburger on your left and a cheeseburger on your right, it's not going to be based on, oh, I'm right-handed, so I'm going to use the right-handed cheeseburger. You're just going
Yeah,
to
it
grab whichever.
is. It's
No.
yeah, it is. If
Mhm.
whatever hand you would use, that's the hand that you would reach for that item.
You just look for the one that's closest to you or the one that you see first.
And hold on. No, now I've really got an argument. So some cultures exclusively eat with one particular hand.
Yeah, because the other one's for wiping your ass.
Yes. So you could say that if they were of that culture, they would 100%, 1,000% every time
Mm-hmm.
reach with that hand.
But that's a human versus a donkey.
Well, no, if you were arguing animalistic instinct, it's the
Yeah.
same as if you put me in front of two cheeseburgers.
Mm-mm.
You're,
No,
it's,
because the animal instinct is higher in the donkey than it is in the human. There's less reasoning. And you took free will out of the equation for the donkey. So if you're just going off of base animalistic instinct, we have the ability to reason, oh, this one's closer and my hand is right there, so I'm going to grab for it with this hand. The donkey doesn't have that.
uh,
Got him.
I don't know, man. I
And
I
we'll
just like I the only thing that I can say for sure in this thought experiment is that I don't think the donkey would just starve.
no, eventually the donkey would become uncomfortable, turn one way or another, and start eating. But
Right.
my argument is not that he's going to starve; it's that he's going to choose whichever hay bale he
No,
wants
I know.
on
But
random
you're
chance.
trying to say that it's 50-50, and
Mhm.
I struggle to to agree with that. I think
Mhm.
50-50 is just a flip of a coin. That's all it is. I don't know.
Yeah, I mean that's statistics in one way or another. You go through you send mice down a random maze, and you have a T-shaped junction where it's coming down one lane and it's going to turn left or right. Whether or not the one mouse turns left or one mouse turns right is going to be solely based on their individual decision at that point. And even the same mouse going over and over again would counteract that. Yes, they might choose similar paths. That's just because they've done it before. But if
But
this is
that
a
animal is making a choice for a reason.
choice means free will. It's not a choice.
True. You're right.
Mm-hmm.
The donkey has no free will.
No. So so the people listening out there, you might have an opinion one way or another, but take a moment to think about this experiment. If you believe that everything happens. I guess it depends on your view of the world. If you are a determinist who believes that everything is already set in place, you might have one opinion on how this works. And if you're somebody who thinks everything in life is based on free will and random chance, then you'll have another view. But in
Sure.
terms of the science of conducting this experiment, it would be a 50-50. If you're talking to a statistician about what the odds would be, it would be like flipping a coin because all the variables are constant. Nothing is swaying one way or the other, and you just have an animal that has a choice between left or right, and it's going to choose randomly.
Wouldn't there be a slight chance though that the donkey does starve?
There's always a chance that the donkey, I mean, if it's dumb, like if it
Yeah,
decides that it can't, like if it just faces forward, I mean, there's a whole different choice. The donkey could, unless the donkey's tied down there, the donkey could walk 10 feet and start eating grass instead of the hay. There's all kinds of factors that can come into play, but even all those choices are random chance.
true.
Whether or not he eats hay or grass, 50-50. Whether or not he eats anything at all or starves, 50-50.
That's a tough one. That was
Mm-hmm.
an interesting thought experiment.
Let us know what you guys think of it.
Yeah,
Comment down and let us know what you guys think of that thought experiment. We just wanted to start off with something a little tantalizing, little mind teaser,
little
if you may.
mind teaser
Mm-hmm.
thinking.
Just tickling your little brain here.
All right, space.
Yes.
Something that we did not get to that I'm immediately thinking about the universe.
Yes.
So, you know how in the new Cosmos with Neil deGrasse Tyson,
Great show, by the way. If anybody's
great
interested in
show.
space, watch Cosmos 1 and 2 Possible Planets. Really good.
So worth it. So, I don't remember what episode it was, but they do a whole like zoom out of the universe and
Mm-hmm.
you start seeing that there's actually like giant sections of dead space where there's
Mm-hmm.
nothing.
Mm-hmm.
Um, and it looks a lot like an atom. Like it's kind of creepy, you know? Like you kind
Yeah,
of
I mean, it's following similar physics, but one thing that there's another physicist. His name is Brian Greene, and he talks about this idea because back in the day, I mean, I wouldn't say back in the day, there was a weird notion going around because the human brain, our neurons, had similar structures to some of the superclusters and stuff that were out in space.
yeah.
And people were like, "Oh my god, does that mean like we're all made of the same stuff? So
We're
is
star
everything?"
people.
Yeah, we're star people, as people like to put on their freaking Instagram accounts. I knew a girl who did that, and she had no fucking idea what space or any of that science was. So that was just her thing. But yeah, so it's a correlation bias, it seems, for us when we look at something and it looks similar, because gravity works differently. Because a small atom does not have the same gravitational effect that a large planet will,
Right.
but things move around in an elliptical or around something just because of electromagnetic pull, and it's going to look very similar. But in terms of like how they actually function, like when you physics is really weird when you get down to like the subatomic and the quantum level. Physics that we understand as normal people who took physics in high school and college, that goes out the window.
Yep.
It means nothing to you. There's superposition of particles when you get down to that low, where a particle can be here or there, or at those two places at the same time.
Yeah.
Just let that go into you. I mean, you're dealing with issues where there's different ratings of infinity. It's not just, oh, this is infinite. No, there's infinity plus one, infinity plus two.
That's where Schrodinger's box comes from, right? With the
Yeah,
cat.
yeah. I mean, it was an experiment basically to see our perception of whether or not something is dead or alive until we open the box, right?
Right, but they
Yes.
use it in quantum physics because it matches up to the whole. Like the particle can be there, but it could also not be there.
Yeah, absolutely. Well, it looks like Spicy's joined us. Hey, Spicy, how are you?
Good. How are you, gentlemen?
Hey, so you just came right at the beginning of our conversation about space. We just talked about whether or not, um, so if you look at a subatomic particle, Gooch brought this up. Subatomic particles look very similar to some of the space anomalies and features that we see on a macro scale. And I was just going into the correlation bias that that human beings have when we look at two things that might have nothing in common, but just because they look similar, we just assume that they act the same way.
Yeah, I mean it's pretty interesting. I kind of like what you said there, where the just because something seems like it's similar because it has similar properties. I mean, I think as people we tend to think in patterns. We try to look for patterns and things to rationalize and make sense of the world around us. So there's this almost comfortable assumption that we jump to, that just because something looks to be similar in that way, that it has to operate identically.
Yep, that's exactly what I was thinking, because we were talking about how there was a trend going on where people try to compare the human neuron to some other anomalies that they saw in space and tried to make it seem like, oh, there's some connection there when there really isn't. There's no real connection to anything that's going on out there. But in terms of space, guys, like, it's so vast. Like, part of the reason that I'm so awestruck by space is the random chance of it. Everything that happens in space is technically random, and it's only based on whatever the principles of the physical laws there are play like. And we don't even know if physics works the same way in the outer reaches of the galaxy. We just don't know. Like, we know that in our immediate vicinity, yes, physics works the same way because we can calculate where things move and how things are working around each other, and we know that physics is the same. But there's parts of space that we can't even see, and we'll never be able to see. That's the scary part. There's parts of space that have gone above the horizon of our view and will never be seen by us again. So we have no idea what's going to happen there. So I mean, I'm really a huge fan of space and astrophysics and all the things. So I'm really excited for this episode.
And I mean, it's interesting when you look at it, that so like I guess I really don't ponder space as much as most or some, that I didn't even think about what did physics look like in like an outer reach level of space. Because I mean, like, all we know is what we've calculated, what we've measured with the constants that we have with the laws of physics, that have been established. And so it's kind of one of those where, we may not know. It's kind of one of those, we assume that this is exactly how it's going to be until we're proven wrong. So it's like that's our basis until we have data that shows counter to that.
Yeah, yeah, that's basically what it is. We have to go off of our understanding of math to understand what's going on out there. A lot of what we see out there, which causes a lot of these like flat earthers and people that don't believe in some of the stuff that is out there. I think it comes from the problem with us needing to understand very high level math to even
Yeah.
contemplate what's going on out there. And I think that's the biggest issue with a lot of people is like if there's a mistrust of science, then there's a mistrust of the processes of getting that science to explain something to you. And then, like the idea that we knew nothing about planets that were even possibly remotely hospitable for us until like 1991. And now there's like 4 to 8,000 planets that we know and have named for possible homes that would work for us. Like, in the span of 30 years, we've already gone that far. And that's just using science and understanding how light works, and the same things that Newton did when he beamed a light through a prism to show the different colors in that prism is the basis of what we're using to understand whether or not a planet has the ability to sustain life. And that's the craziness of it. Like, science is standing on the shoulder of these giants and kind of reaching a little bit further each time and going a little bit further. And everything that we have now is a culmination of lifetimes of works for hundreds of people and people that died before their work even became anything prominent. So space is so gigantic that it's a monumental task, and it's something that I don't think will ever end. Like, you'll always find new things in space that you might not ever understand.
Well, meanwhile, we've got a guy that proved the Earth was round 2,000 years ago with a stick.
Yeah, we had a guy with a stick and two wells, and he's like, "Yeah, the Earth is round, guys."
Hey, I've done all these scientific calculations to show you that the Earth is flat. Meanwhile, your on video scientific proof says that it's not flat.
Yeah,
and meanwhile, like the OGs over here, off in the ether, being like, "Yeah, I did that before with a stick."
Yeah, same experiment that the guy used to prove the Earth was flat that backfired on him is the same experiment that was used like 50 to 100 years ago to prove it already. But he's like, no, I got to repeat this, and that's that. Yeah, that backfired brilliantly. I love that.
It's the classic go to the flat earther and you're like, show your work.
No, you show your work.
You get a D because you got an answer, but it's not the right answer.
No, they're disqualified from participation medals. They don't even
Yeah.
get those. Okay,
You got an answer. Like it's not right.
one that
Sometimes,
one.
you know, the math teacher goes, "I don't even know how you got this."
It's like, I'm just impressed that you got this. It's like, that answer is very wrong. God have mercy on your soul. That's basically
Yeah,
like
that
send him on
movie.
the way.
It's
Like,
gonna
that
blow
was-
people's minds. Find life in the outer reaches of space, and then it's just like, what's a two?
So, to be fair to people that question like science, math, everything, we do have to remember that calculus was created by a complete virgin so that he could prove everything that he was trying to
Mhm.
explain.
Yeah.
So, I mean, I don't know, bro. Sometimes when you create an entire, classification of math and higher understanding, and it's one guy, and we've just built off of what he created for
Mhm.
what, 200 years now?
I mean, it's for me. I think a lot of people have trouble with the scale of what's out there, because like the scale of something micro, like the number of atoms in one fingernail in your body, is an unimaginable number for us. And then the scale of the number of stars in the sky, you look up and like, good luck counting that. But somebody did. Somebody literally whose life was to count stars in quadrants and analyze that. And that's the craziness of it. Like, there's so much out there that is, it's borderline terrifying.
It is. So, and that's what I was just about to say. I think a majority of these people, too, it's hard for them to know that in the grand scheme of the universe, they are literally a speck of sand on a beach that we can walk over. That's all they are. Nothing. And so I'm not saying that you are nothing, nor am I condoning any kind of self harm because of it. But
You are sand.
yeah, but
You mean nothing to me.
yeah, but it's true. I mean, if you think about the big picture, yeah, you pretty much are nothing. Even if you think of just on Earth, when you're dealing with almost what, 8 billion people, right? Moving into 9, you're you're pretty insignificant. I mean, I don't care, even if you're like the CEO of a big company. Yeah, I'm sure people know who you are, but you're still just a blip. So it's hard for people to come to terms with that, I think.
And like, they feel small on Earth. Now imagine a billion Earths in galaxies and billions of planets outside of the reach of someplace you can't even go or see in your lifetime. And that's how small you should really feel. Like, your problems are trivial compared to the immensity of the space and everything else is going on around you. If you feel like you're full of yourself, just take a look up. just just look up. You're nothing. Just accept that fact and live your life, and you don't have to fight it. It doesn't have to be a negative for you in your life. It's just, this is your life. You've 100 years. The earth has existed for 4.5 billion. That's how significant you are. So that's basically what you have to have an understanding of. So I'm pulling. I looked up some interesting facts about space that I wanted to have a conversation with you guys about, and I wanted to kind of get an idea of what you guys think. So when you're in space, everything is silent, for because sound needs materials to bounce off of, air particle, or oxygen, anything that it needs to actually make sound. So it could have the biggest explosion happen next to you and you would hear nothing. That's a crazy fact for me. Because like you think about it, all these movies, if you watch movies and that's your understanding of space, you just think that, when the thrusters turn on in the rocket, you just hear this roar and you're going along in space. No, once you get out of the atmosphere and you're into actual space, it's silent. So how do you know if anything's working? So if you're how do you know if your rocket's working correctly? How do you know if you're not, like, are you feeling the vibrations? Like, how does that actually work? It's trippy, right?
So I would imagine, because astronauts do a lot of training underwater to simulate
Mm-hmm.
space. Plus, the resistance is good for them anyways, because it's going to build their muscles up as they move, and then because there is no resistance in space, but it mimics a lot of it, right?
Yeah.
Um, and so underwater noises and everything are really muffled too. Not
Yeah.
absent, but they're muffled.
Mm-hmm.
So my guess is mentally that prepares them for those kinds of scenarios, like knowing if things are moving. You'd be able to feel vibrations, I'm
Mm-hmm.
sure, through the suit. I doubt everything is completely motionless when it fires off. Um, other than that, literally, I mean, you're right. You're basically trusting a computer to tell you if things are working properly most of the time.
Well, my biggest worry with that is like the isolation of it, right? Because space is already isolating as it is, but then imagine not hearing the normal sounds that you're used to on an everyday basis, right? So that like super sound chamber that they had created, where like no human has lasted more than like an hour in it, without having to like leave. But now you're in space and you're stuck out there for months. Like, are they just pumping artificial sounds in? Like, how do you fight that?
Um, a good example for like normal people like us is if you've ever been in a house where the power goes out, that is creepy because any humming that you've never noticed, all the electronics, like everything dies, and it goes like completely silent. You don't realize how much background noise is actually just in your house until your power just goes phew, and you're like, what happened? I'm scared. And then, like, you know how if you're in like really quiet, maybe out in the middle of the woods or whatever, no wind, and like your ears start to like ring because your mind just mentally it needs sound because we're so used to it. That's probably hard to get used to.
That is pretty crazy.
Yeah, I mean, like maybe out in space, you're not gonna like if you were out in the vacuum of space. I mean, you may not hear sound with like the reverberations, but I mean, like the human skull, I mean, is a very good conductor of sound waves. So, I mean, we all kind of have our own perceptions of our own voice just because of the reverberations we hear. What people hear we sound like, it's not what we think we sound like. And then on top of it, I mean, when you're inside of a craft, you get the reverberations off of the metal walls, the instruments, everything inside. I'm sure there is some level of putting artificial sounds or just not artificial, just playing sounds in there to help with some kind of stimulation when you're on these kinds of missions. But also to the comm system, the way that those work, the transceiver, it's not reverberating off of anything, but you're receiving a signal. So I mean, it's kind of a way to bypass that as well.
So when you come back, do you just have like super hearing? Because all of a sudden you're just bombarded with all the stimulus that you get, or do they have to like put you in like a chamber to like get you used to the sound? Because it's probably jarring.
I don't
Like,
think so because I at least have never heard of it. Because from my understanding, I mean, you're not spending a lot of time out in the reaches of space there. You're mostly in your station, in your craft, with crew members, with things around you. Things can knock against each other and make sounds. You've got the radio if you wanted to play a cassette or something like that. Or like some kind of music player, I'm sure. And then talking with each other, you're able to hear those sounds still. So it's not like it's devoid of sound just because it's in space, because it's in that self containment.
no, that makes sense. And it's just something that I wanted to talk about. Where it was just really trippy for me. Here's another thing that's super trippy. Sunsets on Mars are blue.
What?
Yeah, Mars sunsets. If we were on Mars and we saw the sun setting on our horizon, it would be blue. So according to NASA, there's a blue, the sunset would appear bluish because fine dust from the planet that's up around in the atmosphere makes the sun seem blue to you when you're actually setting out. So instead of it getting yellowish dark for us, it just turns blue.
Huh.
Interesting fact number two. Um, Venus, one day on Venus is longer than 1 year on Earth.
Yep. Yeah. That's really scary. Pluto just recently made its first complete rotation around the sun since its discovery.
That's insane.
Just recently it made that, dude.
That's
Like,
insane.
that's insane.
Like, think about that's just in our solar system. That's just in our solar system. That's the scale that we're dealing with. Apparently they found a planet made of diamonds that's twice the size of Earth. They called it Super Earth. I love
That's
the
an
naming.
appropriate name.
Yep. Oh, guess the cost of how much a NASA spacesuit is.
The cost of a NASA spacesuit.
Mm-hmm.
600,000.
I'm
Not
gonna
even
guess.
close.
Is he over or under?
He's way under.
Is way under?
Mm-hmm.
Are we talking like a 1.2?
Way under.
What?
You gotta be kidding me, man.
Mm-hmm.
Are we talking like a 2 mil?
Way under. Multiply that by 6.
What is it? A $12 million spacesuit?
Yeah.
What are they building this out of? Vibranium?
What the heck? Yeah.
So the entire spacesuit costs 12 million. 70% of that cost is for the backpack and the control module.
Oh, because I'm thinking just the suit itself, but you're talking about backpack thruster, control module, the helmet, everything.
Mhm.
Yeah, okay, I can see how that would be pricey now.
Yeah.
Still,
So
12 million. That's a lot.
the spacesuits that were built in 1974, if they were priced by today's pricing, how much would they cost?
In today's pricing, you said?
Mm-hmm. Take into account all of the things that have gone up in value.
Like inflated?
Mm-hmm.
Oh, God. Are we talking like a $20 million spacesuit?
150 million
Oh, my God.
per suit. I mean, that's the kind of work that they're doing. They're dealing with materials and frontier work that just costs so much money to do. $12 million per person that's going up there. Anybody that does a spacewalk, anybody that needs to go out there uses that suit, and that's what keeping them alive. So that's crazy. And I mean, that's why they need all this funding, is because all this shit costs so much.
Yeah, you're not wrong, man. That's heavy.
150 million, Jesus Christ. So like,
no, go ahead.
No, you're fine. Go.
Oh no, I was trying to pull something up to kind of what you were talking about earlier with like hearing adjustments coming back from space. So I guess from National Institute of Health, PubMed. Mm-hmm. So I haven't looked into the full article, but even the tagline just from researching it, Google real quick. Background, temporary, and in some cases permanent hearing loss has been documented after long duration space flights. So
yeah, I mean that makes sense.
I guess it's true because I mean the adjusted levels would be different with the ambient noise.
Mm-hmm. So the first man-made project that left our solar system was the Voyager 1. It was launched in 1977. More than 3 decades later, it became the first human-made object to enter interstellar space, because it leaves the heliospace, which is like where the sun can actually reach. And then it has to now cross the boundary beyond it, which has the Oort cloud, which is where all the comets and stuff are circling around it. It's not going to emerge from the other side of the Oort cloud for another 14 to 28,000 years. That's how big our solar system is. That's the outer
It's a
boundary of
long
ours.
ass time, bro.
Yeah, it took 30 years just to get past Pluto outside of the heliosphere, and then another 14 to 28,000 years to get across.
So speaking of Pluto, here's a really cool fact about Pluto that a lot of people don't know. So, not only has it just recently completed its orbit around the sun since its discovery, because it takes 248 years for it to go around the sun, it has a couple moons, quote unquote, around it, right? The biggest one being Charon, Charon. Now, Charon and Pluto are very strange because they are locked in orbit both elliptically and centrifugically. So, not only can you not see Charon if you're on one side of Pluto, you can only see it if you're on a certain hemisphere of Pluto. You always see the same face of Charon, no matter what. So Charon doesn't revolve and then you see the back of it. No, you always see the same face, and you'll always see it from one hemisphere of Pluto. It never changes.
Based on my personal experiences, it seems like everything revolves around Karen.
For our sanity, let's call it Chiron. We'll go with Chiron for the Greek pictured. Uranus spins sideways. That's something I remember learning when I was a kid that really blew my mind. And these are just simple facts, guys, everyone listening. The simple stuff that you can look up, but just really cool things that everyone spins and else in the solar system spins a certain way. And the Uranus just decided it was going to spin in a 90-degree fashion. So Jupiter, one of Jupiter's moons, Io, which is one of the moons that they're looking at as possibly has hospitable for human beings, has a geyser that erupts and sends sulfur up to 190 miles high.
I'm gonna just go on a limb and say I don't want to live on that
planet. That's crazy. It's a geyser. It's basically just sulfur that's just getting sent 190 miles into the air.
Yeah, let's try to live on another planet. Oh, by the way, we have a 190-mile high sulfur geyser. You might not make it.
Just live somewhere else. Yeah, no. Apparently, that something that I never really thought of is that a lot of the work and time that goes into a lot of these spacecrafts is to disinfect it and keep it free of microbials, because they're worried that like you're gonna bring this stuff to another planet in case there is life, or you're gonna contaminate that planet with life without even knowing about it and play God. So that's how crazy they have to be about sanitation.
Next thing you know, we bring back a symbiote, or somebody's got this weird little egg that opens up, and then
the world ends. Yes, I'm pretty sure they made a sci-fi movie about that. Yes.
Well, we've made a lot of them. I guess another thing that kind of relates to space that I don't know a ton about because I did not continue with science in my studies in college and stuff like that. But my buddy, he was a physics major in MSU. So he went into astrophysics specifically. When you start getting into like quantum theory and like the things that revolve around that level of science, dude, it's crazy. Like it is first of all, part of it is I don't have the building blocks that lead up to those level courses and that type of thinking. But to me, it's just hard to wrap my mind around some of the concepts of like quantum theory. Just like kind of those kinds of deals there. And one of the biggest thing, it kind of, I don't know what the name for the principle is, but I mean, you guys have probably heard of Schrodinger's cat.
Mm-hmm.
So in that revolving around a quantum principle that it's just a thought experiment, but I mean, the first time I heard about this and they're like, the cat is both alive and dead at the same time, you're like, that's not true. That's not even real. So like you or people are just crazy. But then I mean, you go into it further, it's the principle in quantum theory that the observation of something is what actually determines its outcome, or because it's basically how two things can both be constant at the same time, and that you don't interpret it like basically what makes it a reality of that cat being alive or dead is the actual observation. So this quantum theory that I'm oversimplifying it and somebody's probably going to ream me for it later, but it's just the fact that they're like the act of observing it is what elicits the outcome, not that the outcome has already happened and you're seeing the after image of it.
No, that's
you're right.
actually that's exactly right. It's called the observer effect.
Mhm.
So how I like to explain it to people, like, because it's a hard object, and we can look at this my glass of water, and it's not going to affect the glass of water. But if I have to look at an atom, I have to use things to look at it, and at that level where it's so small, the smallest change can cause it to give you data that's not actually accurate to where it should be, right? So the way I like to explain it is, imagine Neil deGrasse Tyson did this. Imagine you dropped your phone or something on the side of your car seat. Your very act of putting your hand down there causes that thing to slip further and further down from you. So it's basically like you putting your action of putting your hand down there creates more space for that thing to fall and go further and further. And now it's under your seat. So it's like a good way to think about it. Like when you look at something and you want to observe it for a situation where it should be, but it's showing something completely separate, it has more to do with how you're observing it than it is with what it's naturally doing.
That makes sense.
Mm-hmm.
That's
got
fair.
to-
And yeah, and I did leave out the part, obviously, that from Schrodinger's cat, the whole principle is it's in a box with a jar of poison or something like that. And that, is it alive or dead? There's poison being released into the box. I think it's a dude that just needed an excuse to kill his cat.
Yeah, there was a lot of horrific things done, like the white bunny experiment, like a lot of psychological and philosophical things. You didn't know about the white bunny experiment?
No, I know about the mouse kingdom, the rat kingdom that guy made, but I don't know
No,
what you're
no.
talking about.
This I forgot the name of the psychologist. The psychologist um took one of his neighbor's kids and would show them fluffy bunnies, and every single time they'd show a fluffy bunny, he would shock the kid. Like not even his kid, like his neighbor's kid. And he would just every single time, and it at a certain point he trained it to where it just had to be white and fluffy. It didn't even have to be a rabbit, and it would just automatically elicit a fear response from the kid. And
Oh my
like
God.
it's not like he ever fixed this kid. There was some random poor human out there that grew up to be an adult that was just deathly scared of anything white and fluffy.
You pull out a mop.
Just freak out.
Yeah,
So that's the level.
Can you imagine like the white cotton ball on the end of a Santa hat, like walking up to a dandelion or a cattail?
Q-tips.
Oh,
I can't. I'm trying to.
Oh yeah. So the kid's name was Albert. So it's called the Little Albert Experiment. So look it up if you guys have time at home. Just the crazy experiments that they were allowed to do in psychology back in the day. But
Well,
like I said, that's psychology.
they were kind of like done with like no oversight, and obviously it goes without saying that stuff would not be condoned or even remotely okay nowadays, and it wasn't okay back then either. But there were a lot of things that were technically legal to do that weren't okay.
Yeah, I mean,
but
look
it
at
kind of
animal.
well, this kind of goes into a different argument that in our efforts to discover things from a scientific basis or to like discover these things, like obviously that person believed, okay, I need to find out if this can be conditioned to a human mind. This is going to unlock a lot of doors and a lot of information. But I mean, what price are you paying at that point to learn that information? Because this brings in multivariate arguments of like now you're crossing into the philosophical argument of is the knowledge gain beneficial or worth it to the point of the destruction of that individual's psyche, at least at that level. Then you get into like the human rights violations. So
I mean, I'm still sad that we sent a dog and a monkey to space and never brought them home. I mean, that still bothers me to this day about space exploration. Before Yuri went up, they sent a dog. I think the dog's name was Nikita or something. It was like I think, or like I forget the name of the kitty cat. But there was a monkey that got sent up and kind of just like, see ya. I think they left it with like a couple weeks of food and that's about it. Just imagine you're just this monkey and you're just living out in the jungle and then you get captured, put into a spaceship, and then shot off into space with 2 weeks worth of food. You're just like, here you go. But we had to do that kind of stuff. It's just weird parts of science that nobody really wants to talk about. But it's like going back to Schrodinger's cat, we talked about this earlier, but the idea of something being both here and there or both places at the same time is trippy. because it's just basically a flip of a coin. There's also the idea that it's both, something can be both a wave and a particle at the same time, like light. So when we see light, we usually express it as a wave, but it could also be a particle, or it could be both at the same time. And we're basically sitting there trying to observe it and be like, which one is it?
You know what's really scary? That a nuclear explosion could just occur.
What do you mean?
Theoretically, a nuclear explosion could just occur if everything was right for the atoms.
Oh, just because of the splitting of the atoms can happen
Yeah.
anywhere. Yeah, I mean,
Yeah.
it's what's happening in
It's
the
slow.
sun.
Yeah, it is what's happening in the sun. But yeah, it's really scary to just think that, like, it could. It hasn't ever, but it could.
Yeah. Oh, I'm sure that like the conditions have to be so specific to what you're trying to do, and there has to
Yeah.
be a lot of the same materials doing that at the same time, causing a chain reaction that would just never stop. Like, but I mean, hey, I
So
mean,
do you think
that's
there's many nuclear explosions occurring constantly?
things crash into each other all the time with the number
Yeah.
of particles. But I mean, here's the thing: I can't say that because the electromagnetic forces between these particles are very strong. Because like even when my two fingers are touching each other, they're not technically touching. I can press as hard as I want between my two fingers, and my two fingers will never actually touch because the electromagnetic force is that strong between all the atoms and particles there.
All you feel is heat, baby.
Yeah, I didn't touch her.
I think we've just stumbled onto a very unfortunate affirmative defense, criminal defense cases.
Yeah, this is going to be used in criminal defense for a long time. I didn't touch her. Technically, I didn't touch anybody. I didn't even touch my mom when I came
I wanna defend myself.
Yeah, technically it was my electromagnetic force runner, and I named him Jim.
Jim, okay, Jim, you can take Jim to jail. I didn't do anything wrong.
It's my separate entity.
My electromagnetic force has its own personality.
So, speaking of force, another interesting Pluto fact for you guys. There's a really small moon that Pluto has called Hydra. It rotates 89 times in one rotation around Pluto.
So it's just
Yeah. If it was spinning any faster, it would break itself up.
Oh my god.
They knew what it kind of looked like, but they haven't seen it until, was it Voyager that went by it? So they haven't seen any of those moons until Voyager finally went past it.
Mm-hmm.
And he took I don't know why I called it it took pictures of those moons in the best pictures of Pluto we've ever had. And yeah, they looked at those pictures and they determined that if it was spinning, like, it would only have to spin 2 miles per hour faster, and it would start breaking itself up. So if something ever hit it, like a asteroid or anything, and really got it going, that sucker would blow itself up.
Well, that's how powerful these forces are. Is basically you spin fast enough, and 89 times it's not that long. It doesn't seem that big, but the mass of it's literally a city revolving so fast that it's just
it's 16 miles wide. So
it's going to tear itself apart. So, and like this is small stuff, guys. We're talking about our universe. Now think about, there are stars that are hitting each other and exploding with a force that's so unimaginable, that it's so violent that we see pictures of it and it's just cool, pretty colors. But if you were there, you don't want to be anywhere near any of this stuff happening.
We should talk about how scientists are literally looking in the sky, and like, stars die. They know when they're supernovaing and such, which technically occurred thousands of years ago when the light finally gets to us, right? But then there's the really scary ones where they just disappear, and it's a freaking black hole moving through the universe, eating these things. Can you imagine being the first person to be like, well, I'm looking at these pictures from 4 years ago. Those stars are just gone. Just like a black, I imagine like someone took an eraser and is just like drawing a black line and white dots. Like, oh, that just ate stars. Whatever.
Just It's like the deer in headlight scenario where you're just watching it. There's nothing you can do. You're just watching it slowly. Did it just change trajectory? Oh God, is it coming this way?
And the fact that black holes can technically spontaneously appear.
I don't. How would they spontaneously appear though? It
They're
takes a force.
micro. They're micro black holes.
But it would
The
need
most simple
something
explanation is magic.
magic. Okay.
I'll look it up. Hold on.
Yeah, because like the idea of a black hole, black holes are generally created, for those who are listening, by stars that eventually get too big. So the death cycle of a star is that it will eventually not have enough energy to keep its mass tied together in the tight ball. So it'll expand and expand and expand, and eventually it expands too much and it turns into an explosion, and that explosion will create a lot of particles and stuff moving through space going out, and then that itself becomes food for more stars to be formed. But sometimes if the star is big enough, it can actually, the gravitational force of that can actually create a rip in space-time that turns into a black hole. And that's a simplified explanation from somebody that's not an expert in this. So just think about the amount of force that's taken. It's actually tearing a hole in fabric. And one of the things that really helped me understand space time is the whole way of showing space time as a cloth, where you put a ball in the middle of a cloth and you see it, and you can see it moving. You can move it in a circle, it can spin in that cloth, and it's kind of creating this little dent in it, and that's the gravitational force of that object. So if you try to roll a ball past it while it's sitting there, it's going to pull that ball in to the center, right?
So the micro black hole theory was from Stephen Hawking, and the idea is that if you had something like the Hadron Collider, where you're forcing two atoms to hit each other, that there is a chance that they could make a mini black hole.
That's a terrifying idea. Like that we could accidentally send forth a black hole in the middle of our planet just by doing some experiments. But that's it's a theoretical idea, and I guess it makes sense in math. But it's the implications of it are probably very minor compared to what he thinks can actually happen. Like black holes generally, they're so weird. Like when you go close to them.
Oh, hold on. This is really crazy. The final conception is that even if one was created, it would instantly evaporate, either totally or leaving only a very weak interacting residue.
Mm-hmm. That's kind of crazy.
That's really crazy. Can you imagine if you were banging atoms together and you were like observing your the computer's telling you all the data, and all of a sudden everything just spikes off the chart, and then milliseconds, right? And you'd be like, the hell was that?
And then we get Dr. Adam or whatever those superheroes are that just turns into pure energy.
Or we find a forever power source. Dun, dun, dun.
Oh, well, that's what they're trying to try nuclear fission, because the sun does fission. Yep. So nuclear fission is going to be the best way to do it, because there's barely any waste products, and you're not going to have any of these nuclear materials. Because don't get me wrong, guys, like we have nuclear power and it's great, but here's the thing: it creates a shit ton of waste, and we're basically at the point in our we're literally just burying it in the desert, and like our ancestors used to do with their shit, just shit in a hole and bury it. That's basically what we're doing with nuclear material. And if any of those leak into the groundwater, I mean, it's game over. Like they're holding them in cement, and that's just us. There's plenty of other countries that are not as adequate with their waste management as they are here. So we have to understand there's a whole place in New Jersey where they were just dumping toxic materials and radiation materials into a swamp.
3 Mile Island or whatever.
Yeah, it's nuts. So having nuclear fission is definitely going to be the future for us going forward, to try to get some kind of stability in our power, because coal's not going to be it. Petroleum's not going to be it. We're going to have to find something, because all of that is going to go away soon. And I'd rather not have a black hole powering. I feel like it's how every bad sci-fi movie starts. is I created a black hole to create power for the world.
Oh yeah, because that's the moment where you find out that things can actually come through it.
The kaiju are then we have to create giant robots. We got to fight the kaiju. Oh my
Yeah,
god.
yeah, it's Pacific Rim all
It's
over.
all a mess. Come on, let's be real.
I mean, it really blows my mind if we look at like even Interstellar. Apparently, the way they depicted those planets that were in proximity to the dark hole, the black hole, where like one day in like a 1 minute in the actual planet was worth like 10 years for the person up in space. Like that blows my mind, the relativity of time based on how gravity affects you. Like I just can't imagine the time difference. Like even going from somebody who went to another solar system versus the person that they left behind it, when they come back, they'll be younger than their children. That's a crazy fact. Like I don't know how or when, like how would you combat that as a space if we wanted to become a space exploring race? Like
I would say the only way to combat it would be um, you actually send like generational ships out with the intention of like the fourth or fifth generation creating the colony. The fear with that is A, do you do it with like AI and then the AI like grows fetuses, trains the fetuses, right? Um, or do you try to do it with like a large group of people like they did at the end of Interstellar where there was like a ton of people on the couple ships that they had? I don't know, but you know, there's um what do I want to say? I think my fear, if you were going to do something like that, is the the fear that they would lose sight of why they were there. So, like, what if you just like somehow they just forgot after 3 generations why they were even on the ship?
it's like the movie Wall-E, right? They're just in the ship getting fat, no
Yeah,
idea
kind
where
of.
they're going. Nobody has any idea what the plan is. Yeah. I mean, that's a last ditch effort though. Like I can't imagine if the earth was dying and they said, "Hey, you can get on the ship. We have no idea where you're going. We don't know what's going to happen to you. Get on the ship and go." Would you go on that ship?
The Earth is dying,
Mm-hmm.
probably because I'm going to be dead before we get anywhere. So it's true.
It's just going to be like, all right, you get on the ship. We have no idea where we're sending you. You have to spend the rest of your life in space, or you stay here and die on Earth.
Maybe
That's
I would stay and die on Earth. I don't know. It depends on what kind of death we're talking about.
mm-hmm.
Like, is it like a meteor's coming and it's going to be instantaneous, or
No,
like, am I going to get it?
a solar flash just incinerates the planet.
Yeah, I don't know. My fear is that we don't really have the technology yet to anticipate something like that.
No.
Not to mention too, if you look at it from the point of view that okay, there's a solar flash coming, it's going to incinerate your Earth. You know, you got to leave or you're going to die. You're not getting anywhere in space far enough away to escape that solar flash if it's already hitting Earth.
I guess, yeah, that's
So I
true.
mean, we don't because like not only do we not possess the technology, like Mike was saying, uh, with like predicting something like that happening, we don't have the means to travel far enough to escape that reality.
Yeah, I mean, so let's say meteor instead, because we can see those coming from a long ways away.
Well, and the thing is, it's like take your chances, die on Earth, most likely, potentially, if that were to ever come true, you know, or
It would
take
be
your
cool if you
chances out,
did if you stayed and
yeah,
it didn't destroy Earth, though.
or like take your chances out in space where we don't have any real prospects at this point.
If that happens, imagine the group of people that stayed on Earth and we're like, "Hey, you're not allowed to come back. You already left.
So
You
for
We
me,
left
are
there's
the chosen
for
ones.
for me, I mean, there's nothing that could make me leave Earth at this point. Like I would never give up. I mean, this is I would never give up my home planet. Like because like I said, there's no like feasible prospects at this point for anything outside of here.
We need to start getting probes out to these other planets. Like
They have a plan now.
Yeah, but I know it takes a long ass time. That's the problem. So you have to make something that's going to last that freaking long.
Mhm.
And that's probably the hardest part is like it's got to last, 180 years just to get there.
Well, and like, what's
And
our end goal here? Like, are we like looking to actively populate another planet, or
I would
is
say at
this
least
is this a
colonize, wouldn't you? I mean, if you spread, that's kind of the next step. If you can colonize and at least get a few humans on that planet, where if something did happen to Earth, humans don't die completely, right?
Yeah. I mean, it's just you have to have a contingency, and I mean, it's as far as it seems that they want Mars as a contingency option because it's going to be the closest to us. We can get people over there in about 6 months, and I mean, at the very least, it has
To
to be
me, that's not a
something.
contingency, though. That's
No,
more of like a what do I want to say? A gauze pad over the bleeding wound.
well? And honestly, too, I mean, I don't foresee anything super catastrophic at this point that would lead us to need to do that. This is more of a there's kind of a twofold thing in my opinion to this whole exploration colonization.
mm-hmm.
One, it's the curiosity that's just innate in people of wanting to see if we can do it. And in some part of it is probably a backup plan or just something different. If somebody just wanted to go experience that as their life.
Well,
But
they're doing these things with light sails now, where they're sending out these tiny microscope. They're possibly the size of like a computer chip, but they have like recording software and things on there, and they're basically attaching it to a light sail, and they're beaming light at it to send it to I think like somewhere around like maybe like 10% the speed of light, or like maybe even 20% the speed of light,
It's pretty
and
good.
yeah, and they're basically going to arrive at the closest planet to us that's habitable in like 100 years instead of
That ain't bad.
no. So
That
that's
ain't bad at
that's
all.
something they're working with right now to get that set up, which would be kind of cool because
And we talked about that in the last space episode. The
mm-hmm,
number one thing that we should really be focusing on, although I do think that we should be focusing on getting to those planets as early as possible so that we get as much info as we can.
mm-hmm.
The that would to me that should be number two. The number one thing we should try to figure out is how can we utilize or get as much of a percentage of speed of light as the human body can take
Mm-hmm.
to move, because the faster we can do it, the better it is for everybody, really. But obviously, we were talking like there's got to be a limit where like the human body just would not be able to take that, even if you suspended us in jelly, it would just be too fast, right?
But I think
Yeah.
in general, like I think that threshold is a lot lower than people think it is. I mean, like we already have problems with G forces without wearing a G suit, being in incredibly good shape, and going through certain training.
Mm-hmm.
Like light speed travel I don't predict that, at least in my opinion. I've seen nothing convincing, at least to me, that shows that humans would even be remotely capable of sustaining light speed travel.
So I know that getting close to light speed would be hard to do, but I think we had this conversation last time too, and it's a pretty good topic of what you think about or your understanding of the science of it is what kills you is not speed. It's either suddenly getting to a speed or suddenly stopping from a speed is what kills you. So you could gradually get to the speed of close to the speed of light just because there's a natural law that nothing exceeds that speed of light. It just doesn't work. But that might not kill you, but if you try to instantly go to the speed of light, you will die. There's nothing anybody that can do to save you. So like that's one of the things that we had a conversation. I think it's fun exploring like speed can kill you if you come to a stop, but if you are gradual with your speed, you can go as fast as you want and eventually you won't feel anything with that. It's the changing in direction, all that can affect you, but actual speed out in the space shouldn't really have any bearing on whether you live or die.
So I would say that my only uh, concern with that is like the speed that we know of that we can experience currently isn't what harms us. But when you go in speeds of that level, we don't know what those effects are on the human body yet because we haven't been able to test it. Because you're then talking about potential like thermodynamic properties, about maybe potentially your particles in your body, because of the level of inertia and force or whatever is being generated with traveling at that speed, it could superheat the particles in your body potentially.
So this is what I got here. Surprisingly, speed, defined as a rate of motion, in and of itself is not a problem for us physically, like Raj was saying, as long as it's constant and in one direction, which it would be because you're going through space, right?
Right.
The problem would be if something got in your way, you wouldn't be
Oh
able to.
yeah, that spaceship versus space deer collision is bad.
Yeah. Therefore, humans should, in theory, be able to travel at rates just short of the universe's speed limit, which is the speed of light. But assuming that we can overcome the considerable technological obstacles in building faster spacecraft, our fragile, mostly water bodies will have to contend with significant new hazards that come with such high speed travel. Speculative dangers could arise too if humans achieve faster than light travel, which I don't think we'll ever get faster than light, but we can get close to it. Either by exploiting loopholes in known physics or through paradigm shattering discoveries. So, rapid acceleration and deceleration would be the biggest concern. They're saying think about a car crash. When you go from fast to slow, it ain't good. So how do you control inertia when you're moving that quickly? G-forces experienced vertically from head to toe or vice versa are the ones that can be truly bad news for pilots. Blood pools in the head of those undergoing negative Gs. It can cause an engorged sensation. Blood can also swell the translucent lower eyelids, raise up under the pupils. Ugh. Yeah. So I guess this is from Future Magazine. I guess really the concern is if you had to do something fast, would you be able to slow down enough to do whatever you got to do without killing everything inside of the ship?
See, that's the problem, because if you are going somewhere and you're accelerating to the speed of light, you'd have to stop halfway there to decelerate back down to normal speed just to survive that. So it's like you'd have to know something's there way ahead of time before you can even do anything.
Do you think so? You know how the spacecraft have the thrusters, the small little boosters or whatever? Do you think just like a quick like at the speed of light would just send you to the front of the ship? Like if you just like went with it, right, just to start slowing down, you think that would like send you to the front of the ship if you were in the back?
I don't know about that, but I mean, I think just that, even that little change.
But you're moving so fast. That's the problem.
Mm-hmm.
Like, so, yeah, and that's the thing. You're moving so fast that there might not even be enough force generated from those to even do anything. Like, they may just not work at that speed because if they're trying to push in the opposite direction.
That's true. We don't even know.
So, like, there's a whole myriad of issues that would go into that, like the technology to actually have counteracting forces that could be initiated at those speeds. Like I said, I mean, depending on what happens and what you come near, I mean, you might get into like some thermogenic issues or properties.
You think a ship? Well, the nice thing is space doesn't have any atmosphere, right? So,
right.
I think we'd actually be okay. Because yes, if on Earth, if we were moving that fast, we would make a lot of heat. We would probably be turning sand into glass underneath of us, kind of heat, you know. But in space, you should be okay. There shouldn't be any heat created.
It's one of those things that, like you said, so you'd need to have a known distance, like down to the degree, just to be able to calculate, like Raj said, the halfway distance to even begin a deceleration, to safely decelerate your body. But then you'd have to look at what the deceleration rate would have to be from that high of a speed to safely get you there. And then even through that process, I mean, if you think about it, like, and I know it's different, you're dealing more with pressure, but like divers can't just surface immediately when they come up from down below because of the pressure and the way the nitrogen works in your body.
I envision like our first, we'll say 50% of the speed of light. Seems kind of reasonable, right? I would envision humans having to be in like a, like a Bacta tank full of like a high viscous gel for safety. A
Potential.
buffer.
Like a space seatbelt.
Would that
Yeah.
really help though?
I don't think it would.
Because your body is still
Don't?
suspended. No, because I feel like here's the issue with that. Like physics, it doesn't matter if I have something suspended in a gel in a bottle and I throw that bottle at something, that whatever's, if it's an egg, imagine it's an egg in a suspended gel, and I throw that water bottle at a wall and it hits something, that egg's still gonna break.
But the yolk has a higher percentage of surviving that because of the 2 extra layers it has, which would be the shell and the white. So if you chuck an egg at a wall, yeah, a majority of the time, everything splatters, right? But if you were chucking it at the right speeds, in theory, the yolk might survive the initial impact, and we're the yolk. You know what I'm saying?
So you're not just the egg, but you're the.
I'm not saying we're putting them in the gel to hit the brakes when we're going full speed.
Yeah.
I'm saying we're putting them in the gel for the, shit show opportunity that could arise, and we're giving them the best. Because if there's nothing, it can't be like Alien. You can't lay in a freeze chamber because everyone could just go into the side of the freeze chamber.
Yeah.
But if you have a high viscous gel around you, it's gonna affect your motion in all directions, right? And it should, in theory, act as a buffer for whatever.
I think most of the time the gel is used as a life-saving measure in terms of keeping people like sedated or keeping their metabolism really low, so that way they're not needing a lot of food or water, and they can survive much longer. It's a way to keep people in a long journey sedated and within comfortable means while they travel, not really as a way to stop them from dying if the spaceship has to veer off course or something, right? Because like light speed, you're going 50% light speed, and you make a 1 degree correction. That 1 degree correction would just jolt you everything in there, because light speed is everything's going in there. Yeah. And then you add a small deviation and it'll fuck everything up.
At that point, at that speed, even the slightest percentile of a degree would be catastrophic.
The inertial forces.
What you would have to do then pretty much is go 3/4 of the way and then probably deal with it after that. So accelerate for a quarter, decelerate for a third. And then the rest of your travel would have to be manual, which would probably still be, depending.
And what I kind of think is, too, something interesting that I think more on, too, is because I love this kind of stuff, these thought experiments of, like, what would it be like? What would it take? All that kind of stuff. In my opinion, just being human the way we are, the technology we possess, even though we advance technology very quickly and we've made a lot of discoveries, personally, in my opinion, I don't think we're ever going to reach a point where that's possible. I don't think we're capable of traveling at those kinds of speeds or developing the technology to do it. And also, I think that just based on our humanity alone, I mean, like, there's going to be physical limitations that we're just unable to overcome.
I mean, they said the same thing about them Wright brothers.
Okay, to be fair, they just built an airplane because they wanted to get out of Ohio so bad.
Yeah. But they did it.
I don't know, Spicy.
But the thing is, like, a fixed wing aircraft of the basics that they built, those physics are a lot different than what we're talking about with this level of travel.
I honestly think in our lifetime there will be a mission to another planet
Oh, it's
outside
possible.
of our solar system.
It's possible. I don't think in the next 10 generations we'll see anything even close to going at half the speed of light.
No, it's gonna be. Here's the thing: we'll eventually get there. I'm not gonna give humanity the inability to get there, but here's the thing: as you expand this level of science, it takes longer and longer for breakthroughs to happen.
Mm-hmm.
We've cracked the simple science of physics, but now we're getting into the complex shit, the stuff that takes multiple generations of scientists to work together to figure out, just to get to
You
this
really
point.
don't think we'll be able to get up to 150 million meters a second?
No.
And that's a tough sell. Maybe with
I
artificial.
think there's just a lot of barriers to entry on that one.
So what is the top speed that we've ever achieved, I think?
You'd probably have to look at land speed.
25,000 miles per hour.
That's the fastest speed. It said the fastest speed by a spacecraft is 163 kilometers per second, achieved by the Parker Solar Probe. And how many meters a second do you want to go, Mike?
150 million.
Meters per second?
Yeah, so how many kilometers per second did you say?
163 kilometers per second. That's the fastest spacecraft we've created.
163,000 meters per second. That's what that comes out to. And we need to get to 150 million.
Yeah.
I'll be honest, I just don't think it's possible. Because
With carrying
in our
possible.
own,
we have no drag in space. It's 100% possible.
Yeah, no drag in space, but it's still like if you think about it from a perception or standpoint from where we are now, being where you are now and being 150 million meters away in 1 second.
Yeah. 1 second.
Like, guess what? You just went to meet Jesus.
So 150 million meters. Let's do it. Let's do this in miles for us American folks. You went from that's 93,205 miles in a second.
Like, there's no like you do like how long the acceleration would take to reach that.
You circled Earth 4 times in a second.
You got past the sun.
Yeah.
91.419 million miles.
Yeah.
From here to the sun in a second.
Like,
somebody Thanos stabbed you into a sun.
Like, I'm all about the potential of humanity, but there is nothing right now that convinces me that we will ever be able to meet that standard.
And why that number, Mike? What percent of light is that? Is that 10%?
50.
That's 50% the speed of light?
Yeah.
Yeah. And so, like, that is so, like, unimaginably unattainable, in my opinion, that I don't think we could ever even get.
Let's go back down to 10, please.
From here to the sun.
Yeah, in 1 second. Like, and so, like, we would never even get anywhere near
just imagine
the speed of light in general. Like, people think, oh, light speed travel is going to be a thing for people. When you break it down like that, no, it's not.
I don't think we'll ever. Here's the thing: I don't want to say no because
I'm going to say no.
Technology is so advanced, has advanced so much in the last 30 years, and then you just take that into the next 100, 150 years. Like, where are we going to be at?
But we are not thinking of another possibility: the fact that the advancing technology is not limitless.
Why not?
It's potentially. There may come a point where like you can't advance beyond a certain point. We don't have anything to know that the advancement is limitless.
Well, that's why they're creating quantum computing, because quantum computing is going to take our technology to the next level. Right. So quantum computing will be doing calculations that even our most high tier computers now couldn't dream of ever doing. Like the number of calculations that thing can do is almost infinite. So if you have a problem and you need a solution for it, that quantum computer is going through every single iteration and variation of that problem until it finds a solution.
Right. And I'm just playing devil's advocate. What if you finally come to a problem that doesn't have a feasible solution?
Well, nothing in our history has proved that that's correct, though.
It's not
Right.
a feasible solution yet. We have to figure out. That's the thing. All we're doing is, yeah, the computer can look at it from a million different ways, but sometimes we have to add that stuff in.
Computer's like, would you like to go to the sun? Yes.
But no. So, like, even a quantum computer, yeah, it can look at it, but it can only look at it in ways that we basically tell it that it can. So we
Mhm.
have to discover the new ways and tell the computer, you can also look at it from this way, and then it
Mhm.
might open up other things,
Yeah, because
right?
computing doesn't have its own knowledge and experience base to draw
Right.
on. It has defined limits based on what humanity already knows.
Well,
Right. We can
here's the
teach an
thing.
AI.
Yeah,
We can
that's
tell
the
an
thing.
AI to do it.
They've already shown that AI are learning abilities to communicate with each other. When
You want to go to the
the AI
sun.
computer went live and it was communicating in its own way to other computers, it's like, oh, okay.
Yeah,
So,
Facebook, right? They had to shut it down because the AI was talking to each other
mhm.
behind the screen, and they were
Mhm.
like,
It's like, this is not
"What are
normal.
you?"
Pull the plug, pull the
Yeah,
plug.
it was like slashes and stuff, and they were like, "What the heck is this thing doing?"
It's like dot 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 slash
And
dot dot
yeah,
dot dot. Oh no.
and they didn't know what they were talking about, but they were like, "This isn't what we wanted the AI to
No.
do. This is too much."
That's terrifying. I mean, it's cool, but it's terrifying at the same time. I can't imagine just be like, oh yeah, created this new algorithm, and now this algorithm has like 15 different variations that I did not create. What?
Like it's one of those things where like it's kind of the other side of the thought experiment for me, where like, okay, we've advanced technology, we advance these things, we learn new ways, we discover, we let AI do its thing. You know, does progress continue infinitely, or is there a limit to progress?
I think so. I mean, everything we've shown in our civilization so far is just been continued progress.
Progress is limitless. We'll
Mm-hmm.
always find something new, and something will always be discovered that can probably forward something else.
Mm-hmm.
Right. But
There
there may
is
be
no
avenues
limitation.
that we think we can retain that will just never be reachable for us.
I don't believe that.
Why wouldn't it though? That's why
With
is it
enough, with
unattainable?
if you had an indestructible skull, right?
Mhm.
No matter what, and you had an infinite lifespan, if you banged your head against a rock, eventually the rock would break.
Correct.
The scientific process in this sense is the indestructible head. It's just going to
Right.
continue to do it and
But
churn it
that's
until.
the indestructible head is the human spirit, and technically we do have as many lifespans as we want because we can train new people everything that we already know so that they have the head start to continue forward,
Right.
right?
Well, yeah, and that's the
So we
thing.
have
Like,
the unlimited lifespan. We have the indestructible head, which is the human spirit. We've seen plenty of people that have enough human spirit that can continue on with the hardest things in this world and come up with new stuff.
Mhm.
So literally, we can do anything unless we go straight the movie Idiocracy. Unless that happens to us, we Gucci, bro.
It's hard for me to say that, yeah, that it's just going to stop or there's any reason to, just because that's never been in the history of any time somebody said, this is as good as it's going to get. It's always
The
gotten better.
next the next Stephen Hawking, Albert Einstein, Isaac Newton could be watching Coco Melon right now, bro. You have no idea. He's gonna
right.
turn he's gonna he's gonna turn
True.
26, and the professor, it's gonna be like in the movies, right? Where the professor has that impossible equation up there and he's gonna be
Right.
like, oh no, you can do that. And he's like, what? No, you can't. And then the
Yeah.
kid will
Oh,
do
yeah,
it.
you can.
And then
And
you're like,
it could be a whole new level of math outside of calculus that we didn't even take into account for.
true.
Because
Well,
calculus
Because
explains the physics that we
yeah.
know.
And mind you, like, do I think that we have that kind of indomitable will? Yes. This is me playing devil's advocate. They're just like, especially when you're talking about 150 million meters in a second.
Mm-hmm.
Like, to me, there's no, our brains can't even fathom the technology or anything that would be required to make that even remotely a possibility.
okay, but in the Victoria era, their brains couldn't have even fathomed flying in the air in less than 8 hours, going from England to the US in less than 8 hours.
They had to worry about dying on a ship to get to the other side.
Right.
So, I mean, it's the same concept
Yeah,
that
but
you're
I'd say
framing right
we're
now.
also, yeah, but we're kind of amping up the stakes now, too.
Are we? You think that's amping? I mean, okay, yes, 50%
That's
would
pretty
I would
aggressive.
yes, but 10% I don't think is. I don't think 10% is amping up the stakes. I think 10% is achievable easily, actually. Like
I'm
Possibly.
just
if you consider
possibly.
the time frame from the Victoria era to now, and from now to whatever the hell how long that would be, right?
Hmm.
That's
Yeah,
very possible. A lot of things have happened in the past 100 years, let alone 200 or 300 years.
Hmm.
right. And it's just going to determine what kind of discoveries can be made and what's the
Especially if we
application.
can unify as a world. That would be
The,
really interesting
so
if
the
we could
thing
do
is,
that.
just based on the way that people are, I have a feeling that that will never happen.
But we are evolving though too. That's the problem.
Are we?
Are we?
I
I
feel
don't
like
know.
evolution slowed down a bit, but
Why do you think that?
I feel like we're too comfortable for evolution to happen. Like we said in our evolution topic, I think we're at a comfortable area where our environment no longer requires us to evolve.
So are we meant to just create AI that's supposed to evolve then, you think?
I think that's the next step. I think we're going to end up creating artificial intelligence and incorporating it into our biology, and it'll just be that cycle going forward. And what would you want as like the only feasible people that would actually be able to survive interstellar travel and go to other places without having to ever worry about biology are robots.
Yeah.
Those are going to be the only things. So either robots that we create to go explore, or
So what's the point of that then?
what do you mean?
Well,
Well, it's the next evolution, right?
This is was kind of what I was getting to. Is like,
yeah,
at what
I yeah.
point do we not reap any gain from what we've done?
Yeah, because if we're just making machines to do the rest of it, then what's the point? You might as well just
Yeah, you've essentially cut
go
yourself out of
back
the equation.
go back to monkey.
Well, you basically have your intellect inside of a undying creation. Your ability
I
to
don't like it.
see
It's not the
everything.
same.
I
It's
don't
not the
like
same.
it.
And I am can. This is another thing that I'm kind of certain of, and this kind of goes back to my personal views on the world and my faith background and stuff like that. You will
Mhm.
never get every component that makes a person into a machine.
I agree with that.
You don't
There
think?
are there are immutable characteristics and nuances to being a person. It's beyond logic. It's our ability to feel. It's all these other things. It's our faith component. Like, if you believe in the spirituality side of it, then
Hell,
there's just things that you cannot incorporate into it, especially like coming from my background. Like, if you believe in God or if you believe in a creator, you're
Mhm.
not going to be able to essentially play God yourself and to create that exact replication into something like an AI or a machine.
so if you were able to take my brain, Raj, I think I have the perfect build off of what he's saying. If you were able to take my brain and put it into a perfect android, right? Just
Mhm.
like off of Star Trek or whatever.
Yeah.
Would you program fear into that android?
Would I program fear? Well, fear is an emotional response, right? So it
It
would
is, but
be.
that emotional response, fear, actually dictates a lot of what we as humans do. So if you take fear out of the equation,
Mhm.
I might be a completely different person. Even if it was everything that was the same, right?
Mhm.
You take fear out of the equation, any kind of, and this could go for any of those personality traits,
Mhm.
right? I might be a completely different person. If you're not afraid of anything, what the, you're just, you're not really human. You're
Well,
not
and
making,
you
go
start to
ahead.
dive into the psychological argument of developing characteristics like sociopathy or things that you know take over into a negative connotation.
Yeah, it just depends, I guess, on what you want as an individual going forward. Like, there's no next step in our biology that's going to change unless we just start getting bigger heads, and that's going to be our next evolution. But
Hey,
Yeah, and the
Brady.
thing is, I am not, and also that's another thing. Like I said, I'm just not convinced that we can take the consciousness and everything that makes a person that individual person,
mhm.
implant it into an artificial body, whether it's partially organic or not.
Mhm.
It would have to be if you put the brain in there, or if you find a way to basically imprint consciousness into. like computer. We've all seen the sci-fi stuff, you know what I'm trying to say.
Mhm.
But to me, you're losing the aspects that give someone their humanity. You know, it's that fear of mortality, the ability to die, you know, the finite lifespans, you know, the things that we experience, our emotions, not just our logic and our reasoning that make up our humanity. And you're going to start essentially, it's kind of like peeling back the leaves on like on a plant here. You start stripping it away until eventually you just get to a core and it's nothing that resembles what it was before.
Yeah, I mean, so that's it though, because I mean, we have to figure out a solution for traveling outside. I mean, especially if we don't correct our behaviors here. I mean, there's not going to be an option at a certain point. We're going to have to fix either what we're doing here, or we're going to have to find somewhere else to live, and that's just going to be. It's not going to be our problem. I mean, it's not going to be our kids' problem, our great grandkids' problem, but it's eventually going to be a problem.
I still make the argument that as a species, if we're going to continue forward as far as evolution or even just moving up in the galactic hierarchy, I suppose you could say,
Mhm.
that yeah, we should 100% be going to other planets, at least colonizing them. Maybe not setting up like giant populations, but having outposts of some sort.
So here's the thing, though. We would need to be a global society before we even attempt that.
Yeah, and like I agree with that as well because you want to put as much, I guess, money, but in theory, wouldn't be any money if you're a global society, would it?
No, I mean, it's not even money. It's that if the U.S. does it, then China's going to want to do it, and then
Right.
India's going to want to do it, and then somebody else is going to want to do it, and who gets to where first?
Yeah. And
See, that's going to
honestly,
cause issues.
where we're at right now, we're nowhere near even being a semi-unified like world global society.
Mm-mm. So we have to be a Earth-based society before we even attempt any of this. So that's how far ahead we are. Like, and I don't see that happening in my lifetime unless something drastically.
No.
It
I
would
don't see it
take
happening
something
in 2 or 3
world-ending.
lifetimes.
No, because I mean, like, it would literally take something world-ending for everybody to put all their petty stuff aside to
Yeah,
actually
like
change their mind.
until there is a catalyst, like an antagonistic force that forces their hand,
Mm-hmm.
like we're not going to have a need to honestly come together as a one world, like cultural slash like one world entity. It's not going to happen, and that's
So
just
we need to know, okay, so if we knew that there was another habited planet out there,
mm,
Mm-hmm.
and somehow we heard that they were going to attack us, do you think that would unify us?
I think it would
Generally,
help.
yeah.
But I mean, I honestly also think that we're kind of at the point too where like there's every like major power player is going to have their own idea of how to deal with it. They may consult with the others, but I mean, I don't know that even that would make a total unification.
I'm a strong believer of the Star Trek theory for like the trajectory of the human race. So pretty much what happens is like every Star Trek, whatever creature, population, whatever you want to call them, started out just like every human has, like primal. They had to evolve from where they're at, and then there's like a really big uptick in a very short amount of time, and they get to this industrial, maybe even technological, whatever. And what happens is they stagnate for a long time, but they have enough power or self awareness, whatever you want to call it, to where, um, like Starfleet, like the International Council for Galactic Federation or whatever the heck it is, can actually like sense that they're there. So they know that that's a population, and what they do is they actually watch over it, right? But they wait for one particular thing that that population can do before they make contact, because that's how they determine that that society is evolved enough to actually like be a part of this galactic federation, that they actually can comprehend it, that they're not going to be like psychopaths, basically. And in Star Trek, it's if you can hit warp drive. So there's actually a whole movie where they have to go back in time and save the guy who discovers warp drive.
I'm just
And
imagining Rick and Morty, show me what you got.
yes. So literally, as soon as the guy, they save him and everything, and he hits the button and he warp drives from his shack that he has out in the middle of Kentucky or whatever. That's when the Galactic Federation, they immediately come down because they can detect that warp trail, and that's when they make contact with Earth.
Mm-hmm.
So I'm a big proponent in if there are, beings that are further advanced than we are, that they are just watching us and they're waiting for us to hit whatever they've determined is, a reasonable peak.
I could be true, and that's assuming that there's other sentient life out there that's more advanced than us. And
No, I
I don't
know
know.
it's a big assumption, but
Yeah.
I mean, if they were that advanced, they would be able to hide from us. Really,
Mm-hmm. We're looking. I mean, every day we have satellites pointed up at the sky, and we're looking for any kind of faint trail of anything. And I mean, if
But
they're hiding,
if there's a galactic, you can't talk to these people.
mm-hmm.
Now, the only thing is, in every good sci-fi, there's always a rogue that ends up doing something, right?
Mm-hmm.
So it's like
we need
we've
we
been
need
in
that
our
rogue.
yeah, so we've been in our technological era for what, since the 40s, we'll
Yeah.
say. So it hasn't even been 100 years yet, technically. I don't know. That's what I believe, though. Honestly, I think if there is something like that, like a galactic federation, that they're just waiting for us to hit something that they've all agreed on, that like, yeah, they have to be here before we even talk to them.
Mm-hmm. It's a possibility. For me, I just feel like we've advanced. Like you said, we advanced so much in the last 100 years. Like in the next 300 years, I can't even imagine where we're going to be. Like it's going to be ridiculous. Like the technological advances that are going to show up. I feel like every 10 years we see something brand new. 10 years ago, we were using old brick computers with dial-up internet and all kinds of other stuff that we had to worry about. Now it's
Yeah, imagine where this fission thing is going to go now that we've discovered that we can do it.
mm-hmm.
Oh man, dude.
Now, I mean, with even the virtual reality technology, dude, they're teaching how to do operations with virtual technology. You could literally get into an operating room and do an operation in your own head. Like think about people that are physicists that no longer have to rely on going into their brain to figure something out. They can literally see it in front of them, move things around. Chemists can move molecules around and create attachments and see how they want to do stuff. Like it's a huge expanse of ability that's showing up now, and it's only going to get more and more ridiculous. Like by the time we're in our 60s and 70s, we're going to be like, god damn, these millennials are out here doing all kinds of weird stuff. It's going to be unnatural for us to even understand what's going on.
Wasting all that VR potential when you could just play a music game with lightsabers.
Mm-hmm. Nobody wants to play Beat Saber anymore.
Oh, they'll always want to play Beat Saber.
Mm-hmm. They're because they're still going to be playing Tarkov beta, but it's going to be in virtual reality now. Tarkov patch 36.
I forget the name of the program. I'm gonna look this up right now. There's an actual program that is almost like a mod type program that will build a VR profile essentially for games that don't have native support for it. Tarkov is one of them.
I would be fucking sick after one round of Tarkov. I feel like we could do an entire episode on Tarkov. Like an entire episode on video games that really want to just hurt us, and that's going to be one of them. But in terms of space, I mean, there's just so much, man. There's so much that we have the ability to do, I feel like, but we're just not quite there yet in the technological aspect. And I agree with Mike that, there's no end to the possibilities on what we can and can't do. It's just finding the solution, and we'll always find tools to help us with that solution. It's just going to be the way it is. So
Well, I suppose probably call it there.
yeah, I think so. I mean, it's been what, like an hour and a half now?
Yeah, at least probably
Mhm.
longer. So
Well, and my brain don't know the most about the spaces.
so anyways, season 2,
Mhm.
we're here,
Yes.
and we've got, I think it was 15 episodes in mind. So we set some goals for ourselves with this season. Let me see here. All right. So we would like to reach 2,000 downloads by the end of this season. Now, our most recent is we're at 870. Not bad.
No, 1,200 more to hit that 2,000 mark.
We're definitely going to be increasing our social media presence. And we may have a special Twitch thing in plan here shortly.
Yep. So if there's any gamers out there that are listening as well and they want to watch us idiots try to play some very difficult games, we're going to be trying that out on Twitch. And then we'll keep you guys up to date when that actually launches and we're ready to go with that.
We will be posting episodes on Monday now, instead of Sundays. And depending on our viewership and how we start taking off with this, we may end up opening a Patreon sooner rather than later.
Mm-hmm. So we got some stuff in the books that we're working on, but the number one thing for us is we want to give you guys some new content.
Oh yeah.
And hit on some new topics. We definitely want to reach back into. We're going to be doing an episode on Ukraine and some of the other things that we really talked about, and we want to mix it in. These are heavy topics. Sometimes we talk about. We want to mix it in with some fun ones that you guys can listen to as well. We'll be doing more story-based episodes, like we did with the ghost stories and with ghost ships and things like that. So we're going to do a lot of that, and we're going to add some philosophical ones in there as well. So we're going to be talking about a lot of topics. This is just us getting our feet dipped into the water and just kind of seeing where it goes. Next time we'll have Tim and Wix on as well, hopefully, and then we will get a discussion base going for next week. So thanks again, guys, for listening. And we appreciate all your support through season 1.
Yeah, we really do appreciate all your support. 870 is way more than I think any of us had even anticipated. I don't think when we started I anticipated pushing 1,000 at all. But you may have gotten a new intro, but you definitely aren't going to get a different outro. So without you guys, we would be nothing. Every time that you guys download, every person that you recommend listening to us and they download, it helps us gain traction. More traction we get, the more interesting things that we can do in the future, like opening the Patreon and, maybe eventually doing some merchandise. So if those are possibilities that you would like to see, first off, you can let us know. Email, TikTok, Instagram, YouTube, however you want to get in contact with us. We're more than happy to hear you out. But yeah, right now, we're just trying to build our viewer base, our listening base. And we are found on every single website that you can listen to podcasts on, except for Pandora. That's the only one that I don't think we got the traction yet.
Fuck Pandora.
But anywhere else, so if you, I've done it before on other people's phones that would have never Googled Drunk with Questions. If you Google Drunk with Questions, we pop up. We're pretty high on the Google search list. So, please tell your friends, your family, mom, dad, grandma, people that you like, people that you don't like. And is there anything else you guys have?
No, we're just excited to get season 2 going, and I hope you guys enjoy what we have to put out, and I hope you guys enjoy the journey with us through our next 15 episodes of absolute ridiculousness.
All right. Well then, as always, stay ordinary, my friends.
As always, everyone, thank you so much for listening to this episode of Drunk with Questions.
Drunk with Questions wouldn't be possible without incredibly ordinary individuals such as yourselves. Make sure you join the Drunk with Questions crew every Sunday on your preferred podcast streaming website. Don't forget to like, follow, comment, and subscribe on all of our social media pages. And feel free to reach out to us by email at any time.